All right, Miss Harkey just told us to pick up our practice test. Try to get away from that one, but I couldn't. Anywho, let's look at our problem. So as we can see, the problem we have is a derivative problem and a separation of variable problem. So just to refresh our memories, we've learned that the three main themes of calculus are limits, derivatives, and integrals. And of course, as we can see in the problem assigned, the dB dt, that type of notation was made by our good friend Leibniz, who was born in Germany. And then just a little preface, the problem we are about to do is worth 9 points in the AP Calculus test. So we're going to start off with question 5 of the AP Calculus practice test. So the question reads, the rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0, when the bird is first weighed, its weight is 20 grams. If b of t is the weight of the bird in grams at the time t days after it is first weighed in, then dB over dt equals 1/5 times 100 minus b. Let y equals b of t be the solution to the differential equation above with the initial condition of b of 0 equals 20. Okay? The first problem reads, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? And then it says, explain your reasoning. So, what we have to do, basically, is since dB dt is the rate at which the bird is gaining weight, we have to basically just plug it into the equation. So at 40 grams, and at 70 grams is what we have. So we get our equation that is up here and bring it down. So then we get dB over dt equals 1/5 100 minus 40. And then get dB dt for the 70 gram one and get 1/5 100 minus 70. So both these equations then equate to dB dt 60 times 1/5. Oh, I switched them around, but did the same thing. And dB dt 1/5 of 30. And obviously, when you reduce it down, it's just for the 40 grams, the bird is gaining 12 grams per day. And for the 70 gram bird, it is gaining 6 grams per day. So, yeah, and that's part. Okay, so now we are on part B of question 5 of the AP practice calculus test. So, just a reminder, this is 3 points. So, just a little, not really a refresher, but we got to remember that our original equation for dB dt is 1/5 100 minus b. So when we distribute the 1/5, we get 20 minus 1/5 b. And that still equals the same thing, dB dt. So the question is asking to find the second derivative in terms of b. Therefore, yeah, we just find the second derivative. So second derivative equals, so we do the power rule right here. So we get negative 1/5, since basically, remember, there's like an imaginary 1 on that b. 1/5 of that, and remember the variable isn't t, so we have to do a dB dt, because that's what happens when you find a derivative of that. And well, we already know it, it's this. So we can plug this in or this in to find the second derivative. So what I'm going to use is this one, the one on the top. So d2 of db over dt squared equals negative 1/5 times 1/5 100 minus b. And when you distribute that, well, when you multiply the 5s, it's negative 1/25 100 minus b. And that's the second derivative of that. Okay. All right. So part C asks, use the separation of variables to find y equals b of t, the particular solution to the differential equation with initial condition b of 0 equals 20. So we're going to write our equation again. db dt equals 1/5 100 minus b. So we've been doing this recently in class. So remember, what we do is we send the b over to the other side where the other b is. So we would get 1 over 100 minus b, because we divide it out. We divide it out in order to get it over to this side. 1 minus b. And then that'd be db. And then we send the dt to the other side. So 1/5 dt. And obviously we got to find the integral of it. So we put the integral symbol right there. So what we do now is find the antiderivative of this. So as we know, the derivative of a natural log ends up being 1 over a fraction. So what we would get is the natural log of 100, and remember the natural log has to be in parentheses, minus b equals 1/5 t plus c. And remember, c is the constant, and then this the same. It's just like it's the antiderivative. So the next step is we send the absolute value to the other side, or the negative to the other side. So divide everything by -1, and we get the natural log of the absolute value of 100 minus b. Oh, it's absolute value. So we get negative 1/5 t. Technically it's minus c, but again, this is a constant. This is a constant, so I don't think it doesn't really matter. Anyways, so to get rid of the natural log and to isolate b, you gotta find, or we gotta, I guess, get rid of this and then get rid of the absolute value. So we do everything to the e. So when these two are together, they equal 1. So, and then this is brought down. So it's the absolute value of 100 minus b equals e to the negative 1/5 t plus, I guess, c3. So from there we can send so we can get rid of this within the constant, because as we know, when we multiply e or exponents, it's really just adding them. So this would just equal e to the 1/5 t, and then e to the c is a constant regardless, so constant. And we can get rid of the absolute value there. Let me make that more legible. And then, so we gotta isolate b. So we send b over to the other side and subtract this. So what we end up getting is b equals 100 minus e, the negative 1/5 t plus 1/5 t. I messed up a little, sorry. And then c. Given the original value of this, we have to basically plug that into the equation. So b is 0 equal, or well, for start off, we can also have this as an alternate equation for this. It's the same thing. That's kind of what I was starting to hint at. Yeah, this is also acceptable, but yeah, this is just more easier when you plug into the equation. So b in this case would equal 20. So we do 20 equals 100 negative e to the negative 1/5 t plus c. And in this case, t is 0. So what it actually be is 20 equals 100 minus e to the negative 1/5 c. And send that over to this side and subtract this. So what we end up getting is e to the negative 1/5 c equals 80. And then of course, from there again, you gotta find the natural log of each side to isolate the constant to find, I guess, our initial equation. So again, this equals 1, and then we bring down the constant. So 1/5 c, or negative 1/5 c, equals the natural log of 80. And from there, we can just multiply times 5, or negative 5. So this obviously cancels out and leaves this a 1. So c ends up equaling negative 5 natural log of 80. And that equals c. So when we plug it in back into this equation right here, and we plug this in, so we end up getting b equals 100 minus e to the negative 1/5 t minus 5 natural log of 80. Yep, thank you.